Good morning.
Good morning. Welcome back to the Business Process Transformation track, everybody. As a note, we are not doing Q&A at this time, but you can send questions to ecosystem@tradewindai.com, where they will be forwarded to the appropriate parties. And without any further ado, here's Greg and Derek from MetroStar.
Great. Thanks, Derek. Appreciate it. Good morning, everyone. I'm going to go ahead and share my screen here. As Derek mentioned, my name is Greg Sapp, and we are going to introduce you to MetroStar's Onyx platform. This is the Tradewind member showcase for business process transformation. Again, my name is Greg Sapp, Senior Director, Air Force veteran, background in avionics and IT systems, completed my degree in business and have 15 years of experience with both NavAir and NavSea contracting.
Hello, everybody. My name is Derek Whitley. I'm a principal AI engineer here at MetroStar. I'm a Navy veteran as well as a dual PhD in complex system and cognitive science, and I'm currently supporting the Air Force's open platform for avionics learning, which I'll talk about a little bit in subsequent slides.
So today we're going to go over the challenge presented to us for implementing AI and ML solutions into the Navy business processes. Our solution to those challenges, which is the Onyx platform, we're going to give you an overview of that today. We're going to talk about some mission accelerator examples and then give you a video demonstration to summarize our discussions. So the first challenge facing the Navy is how does the Navy accelerate the AI ML adoption into its current business processes? We understand that the Navy is a large, complex organization within the Department of Defense, and it has many business processes that are burdened by a lot of manual intervention that AI and ML could help solve. So how does the Navy bridge that gap between the manual business processes, the data, and the decisions that it has? How can we help you unlock the insights buried into the deluge of data that the Navy collects every single day? Our solution to both challenges is Onyx. Onyx is a platform optimizing AI, ML, and data science lifecycle by securing and expediting data throughput and analysis. Our platform is fully open source, which means that you do not have any vendor lock-in. You're able to run this data platform on top of your existing data lakes. It's customer-driven, customer-controlled. It can scale massively from anything lightweight as a tablet all the way up to supercomputers, and it's certified and fielded to run on U.S. Air Force Platform 1, Iron Bank, and Repo 1, which can also be utilized rapidly and easily onto the Navy's Black Pearl, Party Barge, and Lighthouse platforms. So without further ado, I will let Derek Whitley take over from here and give you the deep dive of the platform.
Thanks, Greg. So like Greg was saying, Onyx is MetroStar's AI ML platform. It was designed from the ground up to leverage industry-leading and familiar open source tools, thus maximizing source control while maintaining full transparency and preventing any kind of vendor lock-in. From a business perspective, the Onyx platform provides a secure end-to-end data science pipeline capable of unlocking mission-critical insights without the need to harvest and store client data. It does this by coming to you as opposed to requiring that your data be brought to it. From a more project-based perspective, Onyx addresses the pain points of three distinct personas: the DevSecOps engineer, the data scientist, and analysts. Each persona is presented with familiar tools that are wired together in seamless fashion to optimize collaboration and productivity. As you can see on the diagram flowing from left to right, Onyx operationalizes data by passing it into our enterprise scalable, security hardened containers. Whether cloud native, on-prem, or the edge, Onyx is able to securely and efficiently manage data flow and access for downstream data scientists and decision makers as per the DoD's DevSecOps reference architecture. Now for the techies, Onyx achieves scale-free deployment capability through Kubernetes native Docker container orchestration, secured by rule-based access control and provisioning with Keycloak. and launching customized Jupyter Lab instances via Jupyter Hub, replete with AI, ML, and data science standard libraries, including SciPy, sklearn, PyTorch, OpenCV, and any other tool you may need to accomplish your mission. Analysis and learning capabilities are accelerated by utilizing parallel compute resources with Dask, MLOps pipelining with Airflow, and visualization with CDS dashboards, Bokeh, Streamlit, and many others. Next, I'll explain how combining each of these popular industry-leading open source components into a unified and secure platform unlocked critical insights and accelerated the mission of the U.S. Air Force 309th Software Engineering Group. So like many divisions, departments, bases, and federal agencies, the 309th is up to their neck in data. Flight analysts for the A-10 Warthog and F-16 Fighting Falcon pore over grueling manual statistical techniques required for flight test regression. Such data are ripe for modern tools and techniques. Onyx was rapidly deployed to aid in the extraction of valuable insights locked behind mountainous data stores subject to slow processes. After graduating from an unclassified and open cloud environment to an on-premises IL6 designation and certified to field, Onyx's 6 core containers made it to Platform 1, Iron Bank, and Repo 1. This allowed for the 309th to bridge the air gap and deploy Onyx in a secret environment to begin harvesting insights. Among the slowest process bogging flight analysts was the verification and tracking of on-screen symbology and textual data. Analysts are required to manually verify that on-screen flight codes match the flight data they are working with. So to relieve that burden, we turn to Onyx towards a straightforward optical character recognition task, which I'll explain next. Older airframes are able to generate between 1 and 10 gigabytes per second of data, yielding a petabyte scale data store per flight. The Air Force diligently captures and stores as much of this valuable data as possible for later analysis. However, much of the process is subject to manual analysis, and doing so on such data quantity is both untenable and desperately wanting for automation. So, in conjunction with the Air Force, MetroStar utilized the Onyx platform to develop a fully convolutional neural network capable of extracting symbology and textual image from flight HUD data. The image that you're seeing on the right is an example pulled from unclassified flight data. And what we were able to do was build a low-side model that was able to operate on this kind of unclassified public flight data, extract the text and symbology, and achieve a very high accuracy rate. And when we passed the model off into the classified environment, when it graduated its way up, it still performed very high with very, very little additional hyperparameter tuning necessary. Usually, the problem being faced, to solve this problem takes between 6 and 10 months. But when subject to the automation process using Onyx, we were able to get that same process down to hours and days. So next, I will hand it off to my virtual buddy, Wilson, a colleague of mine who has prepared these videos for us as we are kind of time constrained. So let's move over to the videos real quick, and you should see.
In this walkthrough, we'll cover Onyx from the perspective of a DevSecOps engineer who's responsible for provisioning and maintaining Onyx as an end-to-end machine learning platform. To start, we have Onyx's authentication layer, Keycloak. Onyx uses Keycloak not only to authenticate, but also to grant permission to restricted resources such as data stores, developer views, computational resources like GPUs or admin access. So we're going to go ahead and log in here. And this will take us to our Jupyter Hub homepage, where you're able to see our customized homepage here on the Jupyter Hub platform, where our configuration of tools are set up. That includes the available servers and the dashboards that have been spun up, which you can also see here, and the admin page, which I have access to since I'm an admin on Onyx. So one of the things that we're able to do through Onyx is that we're able to streamline and automate our setup where we can deploy an entire machine learning ecosystem in a matter of clicks, as opposed to the days or weeks that it would take to involve a DevSecOps engineer to configure an environment from scratch. So I'm going to click through this launch server button. It's going to take us to our server options. Onyx is 100% open source. The only limits to what can be done on this platform are the compute resources available and the talent that's on your team. Because of this, we created this simple collaborative environment where data scientists and DevSecOps engineers can create these reproducible environments as projects graduate from experimentation to deployment. Each of the items that you see listed here is a different deployment of our demonstrations that have all of the resources needed to launch whatever we want to be able to show. So here we're going to click on the OCR GPU example. We're going to hit start. This takes the experimentation and production environment generation to a matter of seconds, as we mentioned earlier. And what happened with that click of a button is where the magic happens. And it's crucial to the value of Onyx. With a click of a button, we just provisioned resources, defined our Python environment, and requested any additional compute resources that we need, such as compute clusters or GPUs. Now our data scientist has access to all of the necessary resources for experimentation. And with that, we're going to move on to the data scientist and data engineer personas. This portion of the walkthrough addresses the data scientist and data engineer personas who are responsible for data engineering, statistical experimentation, and model development. What we're seeing here is a dashboard that we created to work with some heads-up display data, also known as HUD data, pulled from F-16 flights on some unclassified videos to create a prototype model for our partners in the 309th. What we're seeing here is you can see in this dropdown that we have about 10 models that we have access to, any of which will work on all of the videos that we have here. This is stored in one location while the videos are stored in another. You can see here how relatively seamless it'll be to integrate the two here in the Onyx environment. We're going to start with the declassified footage video of the auto GCAS, as well as the V4 of our models. Here we're seeing the different indices of that HUD data that we saw here. So this is the F-16 video footage of what's happening as the pilot is flying the plane. So we're seeing here things like the left and right arrow boxes, which are important to be able to analyze where the plane is physically, as well as the amount of G-force that's being exerted on the pilot, and things like the altitude number, as well as some other important characteristics of the HUD display that we need to be able to pull off. So what we're going to do here is we're just going to click Run Models, and that's going to import that model and run it in real time. So as I sift through the model here, you can see that on the right, we have the information that we can see visibly as humans. And here on the left, this computer vision OCR model has gone ahead and parsed out what it believes to be seeing over the course of this video. And I'm just selecting random frames here. And we can see with a very high degree of accuracy that this is a model that's able to predict exactly what's being shown here on the right, here on the left. So these have been populated across the entire video in just the time that you saw here. This lightweight model is able to produce thousands of predictions per second in order to account for the 309's challenge of having 15 petabytes of data. They need to be able to process this data as quickly as possible. And that's one of the strengths of this model that we're seeing here. So one thing that I want to highlight here is that there had been a competitor working with the 309 before where they had developed a model with a high degree of accuracy in their development environment that bordered near 100% in that development environment. But when it migrated to the 309's classified secret test environment, it only reached about 5% accuracy over the course of a year of development on real world data. Onyx's platform and data science team upskilled the 309's team to be able to deploy this model here that you're looking at in their test environment in 1 week's time to reach 98.5% accuracy. And what you've seen here was run in real time. One of the other aspects that we want to highlight here is a little bit of a value add that we created for the 309th as well, where we're able to create something called an active learning query, where we're able to find where the model is least competent and pull the most relevant information for this model to become stronger in the future. So anytime that an analyst is working with this data set, they can see here that this model got one of the digits wrong, and they're able to go in here and correct it and send that off to the data science team for this model to continue to strengthen over time. And they can even see how unconfident the model was in that prediction. So we determined a threshold here of 75%. So if the model's not at least 75% sure of its prediction, it's going to send this to be highlighted by the team and say, hey, we think this is incorrect. Can you take a look? So this entire approach is driven by a collaborative effort between our data scientists, data engineers, DevSecOps engineers, and our analysts, who all contribute to this experimentation process to deliver these kinds of results in Onyx. The team is what makes these models so great, and Onyx brings that team together in one place. Next, we'll move on to the analyst persona. So this portion of the walkthrough will cover the analyst persona. The analyst role revolves around extracting meaningful insights from complex data and generating value from these tools developed by the collaboration between our DevSecOps engineers and data scientists, providing a continuous feedback loop to improve and train these models. Analysts are the end users for the tool. Using CDS dashboards, we create these low-code solutions where analysts interact with models and large data sets on Onyx. What we're looking at here is a dashboard that's been created to work with a unclassified NASA Chapter 10 data set. For anyone that's not familiar with Chapter 10 data, this is aircraft sensor data that's taken across the entire plane over the course of the flight. So what we're seeing here is a sensor essentially lined up with each of these different measurements, including things like exhaust gas temperature for the different engines, as well as the location of the plane from a latitude, longitude, altitude perspective, as well as the phase of flight. So one of the things that we can do here is we can take this data and parse it rather quickly, where we've just grouped everything by their phases of flight. That includes pre-flight, taxiing, takeoff, climbing, and cruising. And we're able to see some descriptive statistics here for this rather large data set, this highly dimensional data set, where we can see the average across these, where if we were looking at a CSV file with tens to hundreds of thousands of rows of data across 100 columns, it would be very difficult to look at and figure out what's happening. Instead, we were able to see patterns in the data immediately, where the exhaust gas temperature seems to increase relatively drastically the second the plane starts to move. On top of this, we're able to see visually what's happening as the plane is going through these phases of flight. So we're plotting that information here on the left, while the full flight is shown to the right with some information as you go to click to see what phase of flight is happening at which point in the flight. So we're able to visualize here on the left the area that we've selected while keeping the whole story on the right and seeing descriptive statistics laid out above. And as you can see here, we didn't have to re-authenticate for all of these different data sets and data sources that we're accessing. In fact, their credentials are preloaded, as we mentioned earlier, through Keycloak. So your authentication information is kept secure while maximizing the user experience. Creating a dashboard like this would typically involve a front-end engineer, as well as another DevSecOps engineer to spin up the environment and resources to host this dashboard, possibly even a data engineer to ensure that the data pipeline feeds in correctly to this user interface that we're seeing. Instead, the data scientist simply defines the open source tools the environment will need, provides a link to the Python code that creates this interface, and Onyx handles the rest, allowing the analysts to see the same reproducible results that the data scientists saw in their experimentation environment. This is what enables Onyx to go from prototype to fully tested, real-world data validated, deployable model in 7 days rather than 7 months.
Go back to the very bottom and then share. There you go. So that is the last of the demonstration. So in summary of Onyx, it is fully open source. It has been cleared and secured. It's in current operation on Platform 1, Iron Bank, and Repo 1. As you heard and saw, it is rapidly deployable, enterprise scalable, and it is ready to unlock the insights of your mission data. I am Derek Whitley.
And I'm Greg Sepp, and if you have any additional questions, please feel free to reach out to us. Our contact information will be provided in completion of this.
Thank you very much. Stop sharing.
Thank you, Greg and Derek. That was a great presentation. Now, we'll be taking a quick break now. We should be back at 11:10 with our next speaker. Thank you very much.
Thanks, guys.
Thanks, guys.